So now I'm telling you the basic DC motor which exactly looks like. I think you have seen motor DC motor like this, right? So this is the DC motor, or we can say the toy car motor. Okay, so just you have seen the theoretical diagram. Now I am telling you the practical, which how it exactly looks like. So these are the two terminals. One is the positive terminal, one is the negative terminal. This one is the shaft, and this one is the complete DC motor. Okay, so it's a DC motor, so we need to provide it through battery, or we can say it cells, that positive negative dry cells which we are using for our remote also. Okay, so this is the exact internal view of the DC motor. So they remove the upper case, that is of frame. Now you can see I told you that there are what, magnets. So here these are the two magnets. One is the north magnet and one is the south magnet. Okay, the DC motor exactly looks like if you remove the upper case. So I remove all the parts. One is the north magnet, one is the south magnet. This is the shaft, and this is, you can see that this is the what, armature. Okay, I told you na, armature is in this slot like this. So how many slots are there in this? We are having three slots, 1, 2 and 3, right? So we are having how many slots in this? Three slots. And I told you in that in the slots we placed armature conductor, like I placed in the previous. I placed four armature conductor. Okay, so armature conductor is what? Conductor is a wire only, and wire we are having like wire coil, means if we'll wound a wire like this shape, like 1 2 3, it will form a coil. Okay, so if there are three slots, I play shape it like a 3, 1 2 3, 1 2 3, and then 1 2 3, so that it can easily fit into this armature. Okay, understood? Got it? So these are the slots, and we have placed armature conductor in these slots. Now what we have done, laminations. I told you what is laminations. Like suppose we are having a bread. Okay, you cut the slices of bread into thin pieces, and then again you combine the pieces of bread into a single bread. Okay, this is what you have done, laminations. This is what you have done, lamination. And lamination is done to reduce which losses? I just told you, lamination is done to reduce eddy current losses. Okay, so you can see that there are lines like this, right? So what they have done, they have done laminations to reduce losses. They have show you one laminated sheet, like this is a single sheet. So they all cut the sheet into thin slices and then joined it like this, so that it will reduce eddy current losses. Okay, now there is a commutator also. I'll show you commutator in deep. Like this is the motor. Okay, this is the motor. We are having terminal arms. Terminal is connected to arms. Then we are having brushes also, and brushes is connected to the commutator. This is the commutator. See, now you can see exactly the picture for the commutator, right? So here from the terminal supply is coming, positive negative, and it is connected to arm. Then in between we are having brushes, that brushes rub against the commutator. As you can see that we did not connect brushes with a wire or anything. Brushes touches the commutator only. Okay, and it is rubbing against the commutator to complete the circuit. So current is going to, first current is there, current is going to the arm, then arm to the brushes, and then brushes touches the commutator, so the current moves to the commutator. Through the commutator it is connected to the coil. Okay, through the commutator it is connected to the coil. Now you can see how exactly there is a connection, arm, then brushes, then commutator, through coil, and then it would be back like this. Okay, so as you can see that there is a magnetic field around between north to south, that will move the rotor. Okay, it is a simple DC motor which we have studied in the 10th class. This is the basic principle only they have used for the DC motor. Okay, understood? Now I think you can relate the practical DC motor with the theoretical DC motor with which just I told you, right? So in main construction we are having magnetic poles, we are having armature, that is the rotating part, and in armature we are having slots, and in slots we have connected with the coil, and if there are three slots then we are having three commutator segments only. Okay, if we are four slots then we are having four commutator segments. Four commutator segments, here it is 1 2 and 3. Okay. If there are 4 slots, then 4 commutator segment. If there are 3 slots, then we are having 3 commutator segment. You can see from this image clearly. We are having 3 slots now, 1, 2, 3. So we are having 3 commutator segment, 1, 2 and 3. Okay. That's how it converts AC to DC. Because commutator, what is the function of the commutator? That it converts the AC supply to the DC supply. Okay. Understood?